last video, we started our review of polar coordinates. Now let's practice describing regions in polar coordinates. So take a look here. Describe the region with bounds. X squared plus y squared is less than or equal to 1. X plus y is less than or equal to -1. Describe that region in polar coordinates. And when I say describe this region in polar coordinates, we want to have inequalities. We want to have theta is between something and something. R is between something and something. So there's 1, 2, 3, 4 things that we need to fill in here. And importantly, the theta bounds must be constant. But the R bounds may depend on theta. So R bounds might be constant, might depend on theta. We might have one constant, one depend on theta. Okay, so for every time when I say describe this region of polar coordinates, this is what I mean by that. And this will be the very first step that we'll do in lots of our integrals that we'll do later on. Okay, here, so x squared plus y squared is less than or equal to 1. So that's a circle of radius 1. So we're inside the circle of radius 1. And then we want x plus y to be less than or equal to -1. So the line x plus y is less than or equal to -1. It passes through the point -1, 0. It also passes through the point 0, -1. And if we want x plus y to be less than or equal to -1, we're going to be on this side of things. So this region in question here is this little moon-shaped region down there. So our challenge is going to be how to describe this region in polar coordinates, bounds, and r and theta. Okay, and let me just label that point there as -1, 0. That point there is 0, -1. Okay, theta bounds first. Okay, so what values of theta are allowed? So this is theta is equal to 0. This isn't allowed. Theta is pi over 2. This isn't allowed. Theta is equal to pi. Okay, now we're hitting the region here as soon as we have theta is equal to pi. And we're hitting the region, and we're hitting the region, and we're hitting the region, and we stop hitting the region when theta is 3 pi over 2. So what are our bounds on theta? Theta runs from pi to 3 pi over 2. Okay, how about bounds on r? So the way to think about this is for a fixed value of theta, this is the smallest r can be, and this is the biggest r can be. So we want to figure out this distance and this distance are in terms of theta. And at this point now, it's worth thinking about what are these. So what are these in polar coordinates? So this circle is x squared plus y squared is equal to 1, but we know x squared plus y squared. Go back to a slide or two before. R is r squared, so this is r squared is equal to 1. This is r is equal to 1. So equation of this circle here is r is equal to 1. As for this line has equation x plus y is equal to -1. Well, what are x and y? X is r cosine theta, y is r sine theta. R cosine theta plus r sine theta is equal to -1. So r times cosine theta plus sine theta is equal to -1. So we want r in terms of theta. Equation of this line is r is equal to -1 over cosine theta plus sine theta. So now this information here gives us the information that we need to fill in the bounds on r. So the smallest that r can be, going from here to here, that's hitting this line, r in terms of theta is -1 over cosine theta plus sine theta. That's the smallest r can be. The biggest r can be in the orange region is our boundary, which is r is equal to 1. So this is our first example, and this is pretty typical, describing this region in polar coordinates. Theta bounds must be constant. Yeah, we have 4 bounds here. Theta is between this and this. R is between this and this. 1, 2, 3, 4 bounds. Theta bounds must be constant. R bounds may depend on theta. Okay, let's do one more example here. Describe x squared plus y squared is less than or equal to 4. Y is greater than or equal to square root 3 in polar coordinates. Again, theta is between something, something. R is between something, something. We have 1, 2, 3, 4 numbers that we need to fill in. Okay, x squared plus y squared is less than or equal to 4. That's a circle of radius 2. So this is the equation of this circle in polar coordinates. It's going to be r is equal to 2. We also have y is at least square root 3. So let's draw a line segment here at y is equal to, straight line at y is equal to square root 3. And so x squared plus y squared is less than or equal to 4. Y is at least square root 3. This cap region here is the region that we care about. Okay, what to do here? So let's figure out the theta bounds first. So this is here is theta is equal to 0. This isn't hitting the region. We start hitting the region when theta is at this value. And then we're going on, this is picking up theta, this is picking up theta, this is picking up theta here, picking up the region until we hit that theta value. So we need to figure out, what was called as theta 1 here. How do we figure out what this theta 1 is at this particular point right here? And there's a couple different ways to do that. Let's point out here that this is the point. So this point right here is the point when r is equal to 2 and y is equal to square root 3. We need to figure out what theta corresponds to that. Well, y, think back a little bit before, y is r times sine theta. So if y is equal to square root 3, r sine theta is equal to square root 3, but r is equal to 2. So this is really 2 sine theta is equal to square root 3, or sine theta is equal to square root 3 over 2. What value of theta in the first quadrant gives us sine of theta is equal to square root 3 over 2? Well, this is going to be, I guess I should be calling this theta 1 here. Theta 1 is going to equal pi over 3 radians. So the smallest that theta can be here is pi over 3 radians. Okay, so that's 1 down, 1 to go on the theta bounds. Now we need to figure out this theta bound over here. Well, again, this corresponds to r is 2 and y is square root 3. And so copy paste everything down here. Sine theta 2 is equal to square root 3 over 2. But now we're in the second quadrant. What value of theta has sine theta 2 and is equal to square root 3 over 2? In the second quadrant, theta 2 is 2 pi over 3. And there we go. So this is how we figure out theta bounds. Let me just point out one alternative way to do this. One alternative way to do this would have been to say that we're on the curve x squared plus y squared is equal to 4, but y is equal to square root 3. Square root 3 squared is 3. So x squared plus 3 is equal to 4, x squared is equal to 1, x is equal to plus or minus 1. So this point here is 1 comma square root 3 and negative 1 comma square root 3. And now do like arctangent to figure out what theta corresponds to these points. You'll come up with the same answer. Okay, so we've got everything done here except for r bounds. For a particular value of theta, like that one in the region we care about, the biggest r can be is when we hit the circle. R is 2. The smallest r can be is when we hit this line right here. Y is equal to square root 3, but we already said that y is equal to square root 3 is r sine theta is equal to square root 3. Divide both sides by sine theta. R is equal to square root 3 over sine theta, and that's going to be our lower bound. Okay, and so this is our description here of this region in polar coordinates. So now in future videos, how do we use these when doing double integrals?